Hello friends, welcome to my channel Chemistry with DB. So here is in the time of flight series question. This is the fourth question and perhaps the one which really bothers the students the most as per my experience. So this is a two-part question. In the first part, we are supposed to find out the mass in kilogram of one ion of Br79. So you know that the MR of Br79 is 79 grams. That's the mass of 1 mole of bromine ions. So, if 1 mole of bromine ions is 79 grams, then in that case, 1 ion, so therefore 1 Br positive 79 ion would be 79 divided by the Avogadro times 10 to power 23, and this is going to be in grams. So if we want to have this in kilograms, we'll also have to multiply this, divide by 1000 as well. When we do that, then by calculating we'll get the answer as 1.312 times 10 to power minus 25 kilograms. So all we have done is just converted the molar mass to mass of one ion by dividing by the Avogadro and 1000 to have it in kilograms. So that's first part tackled. Now second part, you must be thinking that we have not been given the kinetic energy. We have also not been given the distance, which is the length of the flight tube. So how are we going to do this? So it's easier than you might have thought. So let's see how are we going to do this. So you see kinetic energy for both Br79 and 81, this is going to be the same, right? So therefore the kinetic energy for 79 is going to be its half. If I write as M is 79 for the Br79, right, divided by the Avogadro and times 1000. This is the mass of 179 ion times d squared, which is the length of the flight tube, divided by the time taken, which is the t, or let's put the time here. Yeah, so time is 6.69 times 10 to power minus 4 and square of this because it's t squared, and that's equal to the kinetic energy for the 81. So 8 for 81, it's going to be 81 divided by the Avogadro times 1000 and then times d squared, which is the same for this one as well, and x squared because x is the time taken by the 81 ions. Now you see what are the common species we are going to cancel out on both sides. Half is common on both sides, we are going to cancel this. Avogadro and 1000 is common on both sides, we will cancel this. D squared is common on both sides, we can cancel that also. So when we arrive at after this, we will have 79 divided by the 6.69 times 10 to power minus 4 squared is going to be equal to 81 divided by x squared. X is the time that we have to find out. Now when we do this, then x is going to be the square root of the whole thing. So this is going to be 81 times the 6.69 times 10 to power minus 4 squared divided by 79. So when we calculate this, we will get this as 6.77 times 10 to power minus 4 seconds. As you must have seen, you see it became very easy when we cancel out the common species, didn't even bother about calculating those complex calculations by 79 and to find out the mass in kilogram, because that's not necessary, because these figures are in any case they are going to cancel each other out. Another point to be noted here is that there is not much, always have a cross check to see that the time taken for 81 ion is not going to be substantially different from the 79. It's just a tiny bit, from instead of 6.69 it's 6.77. Why? Because 81 was little bit heavier, so therefore it took a bit longer to traverse through the flight tube. So this is kind of a cross check for you to see whether your calculation is right or not. If the answer is far off, then you please check your calculations again. I hope this you were able to understand this question better now, and good luck, and I'll see you on my next video. Take care and